Good day, learners. You are welcome back to our mathematics class. In today's class, we are going to be looking at another interesting topic, which is integration. If you could recall, in our previous classes, we have discussed on differentiations and the principles in differentiation. So in today's class, we are going to be looking at the opposite of differentiation, which is integration. Just before we move on properly into this topic, I remain Latif Ismaila Akomi, your mathematics and chemistry tutor. If you are a new member on this channel, kindly subscribe to my channel and click the notification bell for my subsequent content. When you click the bell, it pops up. Click the personalize, then you can be seeing our subsequent classes. So, let's dive in. Integration. Integration, as we know, is the opposite of differentiation. And it is represented by a long S. Generally, when we have, after differentiating, we are going to arrive at dy, dx. So this is telling us that we have differentiated a particular function. Then we introduce the symbol of integration, which is a long S. Let's say equals to x raised to power n. I want to integrate this. Let me cross multiply. If I cross multiply, I have integral dy is equals to integral x power n dx. Fine. How do we integrate? Let us first of all move back to our differentiation. To differentiate, it means you are going to subtract 1. To differentiate, you use the power to multiply the coefficient, then subtract the power by 1. But in integration, you are going to add the power by 1, then divide by the same power. That is, here now, we're going to integrate dy. When you integrate dy, since we have a constant, we're going to have y. And that y will now equals to integration of this one give us x raised to power n plus 1. Then you now divide this by this power, which is n plus 1. Which means that the general formula for integration is addition of 1 at the power, then divided by the value you got in that power. That is what? N plus 1. Indefinite integral. In this integration, we are going to be talking about indefinite integral and definite integral. But let us look at the indefinite integral. Let's look at this function. Y is equal to 10x plus 3x. When we differentiate this, we are going to have dy dx. Differentiation of this will be 3 multiplied by 10. We have 30, x power 3 minus 1 in differentiation. Then plus, there's 1 here, 1 times 3, we have 3, x power 1 minus 1. Nope. In a function, or let me say in a letter or a figure, there are 3 attributes that we normally have with them. If you have 3 this way, there's 3 attributes there. It has positive sign before it. It has power of 1 and it has divided by 1. All these 3 attributes will not be written until when we need them. Here now, this s is carrying the power of 1. So we have to show that 1, then minus 1. So here we have 30x power 2 plus 3x power 0. That is 30x squared plus 3. That is our dy dx. Are we here? That's our dy dx. From here now, we want to integrate this. We want to integrate it. Then cross multiply. When I cross multiply, I have dy is equal to 30x squared plus 3. Don't forget we are integrating. We are integrating. Put the sign of integration. Okay? Sign of integration. Then the s will come here. The x. Now, We can expand this integral dy equals to integral 30s squared dx plus integral 3 dx. Since there is no value here at the left hand side, there's no value, let's assume it's 1. So we're going to have y, and y is carrying the power of 1. And don't forget, y is power 0, x is power 0 is 1. Then add your 1 to it. Divide it by 0 plus 1. That's this power. Is equals to. Come to this side. 30 x power 2 plus 1 over 2 plus 1 plus 3. Now here this is a constant. As we say, this is 1 that is there. And how can we get 1 as we did it here? And what we are dealing with is the x. It's not the x raised to power 0. Because anything raised to power 0 is 1. 1 multiplied by 3, we have our 3. Then we are going to add our 1 divided by 0 plus 1. 0 plus 1, we have 1. 0 plus 1, we have 1. This gives y equals to 30x raised to power 3. That is 2 plus 1 over 3 plus 30x raised to power 1. 0 plus 1, 1 over 1. Finally, we have 3 here, 1, 3 here, 10. We have 10x raised to power 3 plus 30x. We have come back to our normal equation, y equals to 10xt plus 3x. Now, what of the second function? That says y is equal to 10xt plus 3. Let us differentiate this. dy dx is equal to 3 multiplied by 10, 30x raised to power 10, then subtract 1, plus, don't forget that in differentiation, the differentiation of the constant equals to 0. This equals to 0. So we have dy dx is equal to 30x raised to power 2. This has become 0. Fine. We have differentiated. The next one is to now integrate. Introduce the sign of integration. Dy dx equals to integral 30x squared. Cross multiply. When you multiply, I have integral dy is equals to integral 30x squared dx. So my dx is coming here now. When you integrate this one, as you know, there's a constant here. Y is power 0 plus 1 is equals to 30x is power 2 plus 1 over 2 plus 1. So y equals to 30x is power 3 over 3. 3 goes in, 3 goes here, we have 10. Y is equals to 10s cubed. When you look at this, we have come back to where we are coming from, but something is missing. What is missing is this constant, 3. So that is why, after integration, we will now put a constant and say y is equal to 10s cubed plus a constant c. Sometimes you see k, meaning a constant. So in this place also, we can say y is equal to 10s cubed plus 30s plus a constant c. So this type of integration is what we refer to as indefinite integral. There are some basic integral functions that are very important when we are dealing with integration, especially we that we are writing JAMB examination. These are the basic integrals that we have to know very well. 1. Integration of cos x dx will give us sin x plus a constant c. Meaning when you integrate cos x, you get sin x. Fine. 2. Integration of sin x dx will give us minus cos x. You had a constant c. Also, integration of 1 over x dx will give us ln x plus a constant c. While integration of e raised to power s dx will give us, it will equal to e raised to power s plus a constant c. So, this particular aspect, ln x, 1 over s equals to ln x. Ln x also is the same thing as saying log e to to this x plus a what constant c. So this is at the end of this class 1 of the integration. We are going to move on to the next class. In this case, I want you to look forward for the next class. If you find this class interesting, kindly subscribe to my channel and click the notification bell for my subsequent content. And don't forget to share to other members, to other students, for them to also benefit from this immense class. So I remain Latif Ismaila Akubi, your mathematics and chemistry tutor. See you in the next class. Thank you.